Okay, so number 11. Number 11 is asking us to add vectors u and vector v. Okay, so if I wrote u off to the side, which is negative 1, 6, and I'm going to add vector v, which is 8, 2, I'm simply going to add these down and look at negative 1 plus 8, and you get 7. Just like you would do 6 plus 2, and you would get 8. So our resultant vector, which is u plus v, otherwise what they're saying is w, can be shown as 7, 8 is going to be the resultant vector. Okay? And we're being asked to do tail-to-tip method again. So let's first start off with vector u. Okay? So let's do vector u. Vector u, we can start again at the origin as a good rule of thumb, and I'm going to travel a negative x, or a negative 1, and then up 6. So negative 1, up 1, 2, 3, 4, 5, 6. I'm going to end here, coming from the origin. That is vector u. Okay, so let me draw that just a little bit better. And then I'm going to add the second vector, which is vector v, from this point to travel 1, 2, 3, 4, 5, 6, 7, 8, up 2. So I'm going to end here, coming from this tail-to-tip method, and the vector, the second one, would look something like this. We're going to label this vector v. And last but not least, if we wanted to eyeball and trust that the first two that we did were in fact correct, I could say that my resultant vector would look something like this, calling it u plus v, or in this case, what they're calling it w. And this is how we want you to be very methodical and exact and precise with the graphing on the test. And we could check our answer simply by, does it have a 7, 1, 2, 3, 4, 5, 6, 7, and then an up 8, 1, 2, 3, 4, 5, 6, 7, 8. And sure enough, it does as far as the resultant vector is concerned. It's that running that route that we were saying in class as far as the x, y components are concerned with.